welcome to another edition of the Alliance's Poly Podcast, where today Dan Landy and Peter Dyke are talking to our good friend John Trimble from SECOR. But before we bring John on, Dan, how's it going?
It's going great. I'm excited for people on YouTube because we now have these nice PE Alliance blue backdrops for everyone to see. Yeah, your blue shirt, you look great.
Yeah, well, it's the uniform. So, Dan, we've just finished the AWWA ACE conference, which was another great showing for the Alliance and HDPE pipe. Tell us what's going on in your world in the engineering program and how are things going?
Yeah, it's interesting that I never thought that I had a cyclic job, and I'm finding out the last year or two that we do have a cyclic job. So we're deep in heavy construction season right now, getting more questions about things that are maybe getting second guessed or questioned or anything that can come up in construction. So pressure testing, stuff like that. When people think they understand it, but when they get down to the nitty gritty, they still have a little bit of concern, which is no big deal. We're here to help. But yeah, heavy construction cycle, I think throughout the US and some places have quicker seasons than others. So some projects are more urgent to help people with.
Yeah. Well, speaking of pressure testing, what's the rule that we're following these days? You know, PPI took their guidance out a couple of years ago, and now they're just deferring to ASTM. So, give us the top line. What are we supposed to do with pressure testing?
Yeah, so the question I'm getting most often with pressure testing is for some reason, this happens a few times a year where people will leave the pipe pressurized for an extended period of time. But ASTM does have guidelines on that. You want to, limit the amount of time it's held at an elevated pressure. So it's typically stuff like that. For the first hour, you're allowed to introduce makeup water. And then after that, you have to roll back to your exact test pressure and try to stay within an allowance for, I believe it's 4 hours. Um, so yeah, pretty easy. One thing people forget is, if you're in Texas and you start that at noon, because HTP expands, it's really difficult to stabilize the test pressure because the pipe's expanding, due to that UV radiation. So it's just little tips and tricks like that, which is why I always encourage people to have a better relationship with their distributor. They have all that know-how and how to.
Yeah, that's for sure. So, on those hot days when that pipe's already expanding, probably not a great time to manage a pressure test. So, your guidance is, hey, start it early in the day. And Dan, are they running at the polyethylene pipes pressure, or are they running at their working pressure times 1.5?
Wow, you're putting me on the spot because we had a heavy conversation about this last week. The pipe manufacturers are going to say 1.5 times the maximum allowable operating pressure, or so the DR equivalent. DR 11, 200 psi. They're saying, "Okay, if you want to test it at 300, you can." And I'm sure our special guest John Trimble today can walk us through later some of the steps and why it's difficult. But HDP does expand. It's this pumping technologies involved in pressure testing aren't the most sophisticated. So I think it's better to do 1.5 times the operating pressure of the system. If you're operating a line at 100 psi, test it at 150. It's just a lot easier and more simple to conduct the test.
Yeah,
And then,
and at the end of the day, we're just looking for a leak. So
yeah, and just because we're talking about this is our only recommendation. The P Lines does not formally recommend pneumatic, although there is an ASTM standard for it. So that's my disclaimer to keep my job.
good work. Well, Dan, you came to me with this idea. Let's talk to this guy named John Trimble, and John has been a fantastic advocate for polyethylene pipe for decades. And every time you and I talk to him, we learn something new. So we thought, hey, let's bring him on the podcast. And we grabbed him in between assignments out in the field. So with that, John Trimble, SECOR, are you there?
I am here, Mr. Peter and Dan. How are you?
There he is.
Always good to see you. I don't have a fancy blue background though. Need to figure out how to do that.
Well,
What
we
color
could,
red is Secor red? Is that what's the exact color red?
yeah,
Well,
get the
it it
Pantone number for SECOR
it's
Red.
certainly from my perspective, going to the other school in Texas is not maroon.
Okay, okay. Not an A&M guy, understandable.
Not an A&M guy. There you go. There you go.
Well, John, welcome to the podcast. Long
Thank you.
overdue to have you on the podcast. And, as I was mentioning in the warm up here, we're getting more watches on YouTube now than we are listens on the many podcast channels. So that's why we do the audio and the video these days. It seems to work out better for our audience. Can you tell us who you are, what you do, and just a little background on John Trimble?
Yeah, so I've been fortunate to be in the polyethylene pipe industry and fitting industry for roughly about 38 years now. Started out selling gas distribution and then moved into industrial and water infrastructure and a lot of oil and gas. SECOR has been heavily involved in the energy infrastructure and water industries for all of our time, and you learn to be quiet and listen to a lot of smart people, and eventually you learn things. And being out in the field and helping with the macro fusion equipment, as we're a big distributor for them, it makes a world of difference.
So, John, when you unofficially became one of my many mentors,
Hmm.
I don't know if I've ever shared this with you, but the reason why was I think it was 2022 or 2023. I went to Infusion, which is McRoy's annual conference, and I'm in a room, a lot of people, a lot of smart people, and I said to someone, I'll text you who it is. I don't want to say it on the podcast. And I said, who are like the most underutilized guys in the industry? Like who knows a lot and people don't call and bother them that much. And they said, oh, John Trimble. So, so years go by and we have a question one day, and I know on spacers and casings, and I call you
Yeah.
and you're like, hey, like, why do you keep asking me? Like, I'm not an expert on this. And I was like, John, as long as you keep answering, man, I'm gonna keep calling you.
Yeah, you end up learning a little bit of field trade secrets and how things work and how things don't work. I was very fortunate early on in my career where an engineer took me under his wing and said, I know you're trying to sell me all this stuff, and I understand that, but let me show you a real world environment of how things are going to work. And, you know, that experience and learning from people really pays off dividends in the long run. And you don't try to be an expert in everything. You just say this is what has worked well with other people, and that's always suited us well.
Yeah, let's probe that some more. But first, John, tell us about SECOR and where SECOR fits in the market in your trade area.
Yeah, so SECOR is a integrated, we're a large distributor of polyethylene pipe for water and for gas and for industrial and mining. We manufacture fabricated fittings and spool assemblies up through 48-inch currently is our production range, but heavily involved with larger diameter projects that go all the way up through 65-inch. So we end up working with the owners and engineering firms to help them with specifications and technical requirements, and then more importantly, hopefully get the sale on the products, and then be able to move that into the construction phase. The construction phase is real important to make sure that the contractors and or the city employees that are going to be installing the infrastructure understand how to do that. It's all well and good to just sit there and fuse a piece of pipe, but you have to think, if I have to hit a hard point or where my obstacles are going to be, what fusion needs to be done first, what our requirements are for directional boring, and how we're going to do those tie-ins. And that's where we really try to shine, to basically bring the whole package together versus just I sold you a piece of pipe.
So you guys are polyethylene only, is that it?
Yeah, we don't do, we'll do transition fittings, Peter, from poly to steel or to a flange connection, but we do not sell any other piping structure except high density polyethylene pipe.
Got it.
So a little bit of polypropylene for some of the mechanical markets, but for the most part, 100% polyethylene. No PVC, no steel.
You talk a lot, early on in my career with this, I was like, okay, distributors, they do distribution. But one of the key elements about SECOR is so exciting is you guys are fabricators. You're making a lot of custom fittings. Help me understand that. And you talk a little bit about how you sell those to your competitors. How does that work? And how did fabrication become such an important part of your business?
Well, it started off. I appreciate that. We don't try to be all things to all people, but we're very good at what we do. And so, as a result of that, we got into fitting fabrication with some specialized equipment to actually manufacture the fittings, and that has led us into custom spool assemblies that were first utilized in the oil and gas industry, and then the water utility industry, and now lastly into the data center market. The data center market, because of the breadth of scale on some of these construction builds and the speed that they needed, some of the other distributors that have a relationship to be able to provide the pipe and the fittings need additional resources to get enough fittings out there so that they can install these lines. And we've been fortunate with our quality and our way that we produce the product and quality control of it to be able to supply those to other distributors that have a relationship that are trying to build out these water infrastructure builds for these data centers. Conversely, also on large municipal water projects, we're seeing a tremendous push towards the water infrastructure market for a lot of the towns. Of course, here in Texas, it's either feast or famine. We're either completely wet, like I am today, with a little tropical system in the Gulf, but then 2 months ago we were completely dry. So a lot of the reservoirs are going dry. So we were fortunate to be involved in a lot of large diameter infrastructure builds that require fabrications and fittings. So you you get a contractor out there and he wants to just fuse up the pipe, but now here's a T with a reducer and a riser, and we need to come up to what we call a camelback, which is an above ground meter set or going into a vault structure. They want to kind of prefab that entire assembly, have it on site where they don't have to think too much. They can just grab it and butt fuse one fusion, and they're done. And that has led to a lot of our fabrication, including the addition of a new facility that is dedicated specifically to fabricated fittings and spool pieces. So we're kind of excited about the growth of that market.
Yeah, thanks for explaining that. So speaking about growth in the market, Dan and I like to talk about the 9 major markets for pipe. Polyethylene dominates 5.5 of them. What are some of the things you've seen in the last decade that has really changed the marketplace? Is it the time you're spending? Is it in the field? Is it the municipal market? Is it the gas market? Is it landfill? What are the couple of big trends you've seen over the last
Yeah,
10 years?
I mean trends. So if you think about it, we started out, with polyethylene for directional boring and the telecommunication market. Everybody forgets that, when the internet was just getting started, that companies like Level Three and Vivix and Williams would all of a sudden have all this pipeline right away, and they would say, well, wait a second, we can lay these fiber optic lines to interconnect stuff. So polyethylene pipe really went from kind of an afterthought on the telecommunications to, hey, I have to have a lot of pipe for all these bores so that we can put all these fiber lines in it. So that's worked out really well. Then from there, we transitioned into cogeneration facilities where we didn't have enough power. They didn't want to build new nuclear power plants. So we ended up with combined cycle, which is a natural gas powered uh, uh, combined cycle unit. They used a lot of water and a lot of polyethylene to fabricate from the cooling towers to the HRSGs. so that they could generate the electricity. So that was unfortunately the start and the decline of some of the Enron assets. If people remember the Big E.
Oh, man, you're going back 25 years.
Well, you said go back a little bit
Yeah.
and changes, Peter. So uh, then, of course, we got into the pipe bursting with the sewer and water market. Very easy to use polyethylene pipe to pipe burst old clay and concrete asbestos pipes and old infrastructure for slip lining for the water market, most specifically the sewer market. That was the easy deal. Mining has always been there. Natural gas distribution has always been there. Of course, that's a little cyclical sometimes on the housing markets. And then, of course, oil and gas. Oil and gas is a boom and a bust, and a boom and a bust. So, in all of my time, I've been through 4 booms and busts on the oil and gas. But with the advent of the hydraulic fracturing for fracking that the Mitchell companies developed really in the Barnett Shale, which is over by Dallas, that really opened up the frontier for a lot of these oil and gas wells that would need polyethylene pipes. So today, in the energy infrastructure, we have a tremendous amount of polyethylene pipe going in for produced water lines, which have a high chlorine and salt content, where polyethylene is the choice for moving this produced water. A lot of that is being tried to be recycled and reinstalled during the fracturing and the hydraulic fracking process. But also, all the natural gas that we're pulling off of these wells are going to processing plants that are then being turned into other petrochemicals that are going back into the market. Plus, with the advent now of the data centers and the power demand, we're starting to see a resurgence in the Enrons and combined cycle type power plants that natural gas was used for to produce the electricity. The data centers are taking a tremendous amount of energy to produce the chips, or not the chips, but to produce the data and the power required to run the servers. So as a result of that, we're seeing now a resurgence in the combined cycle power plants to come online to power these plants.
What does combined cycle mean?
It's just a combined cycle is like a natural gas fired turbine that then heats up water, and then the water basically drives a turbine meter to create the electricity.
Oh, okay. So it's just a
It's just a
turbine.
power plant, turbine power.
Yeah. All right. So what I'm hearing is that, gosh, go back 30 years, lots been going on. We started basically with conduit, and then it's kind of morphed into all 9 of these markets. Culminating now in the data center boom, which we're sharing with legacy materials for sure. But one of the things I noticed, John, is a lot of these data center mechanical contractors and civil engineers really like the concept that polyethylene doesn't leak. Have you seen the same thing?
Absolutely. They love that it's a monolithic system, that once they have a fused joint, they don't have any issues with any sort of water leakage or water loss like traditional bell and spigot type piping would have. They like that it can be installed overhead in a building, underground, a multitude of uses for the polyethylene pipe.
John, I just heard something crazy for the first time last week, but the oil field, they will lay coiled pipe and then they'll go back and retrieve coiled pipe. Have you seen that?
Yeah, they would do that, Dan. They would use that typically for the water going for the drilling. So typically it was 2, 3, and 4 inch pipe, and they would coil up through a specialized drum that had a mechanical drive motor on it. They would coil up roughly on 3 inch. They would get about 8,000 feet on a drum, and they would lay that out. So that was typically for water to run the drilling mud and the fluids during the drilling cycle. And then once it was done and they're moving the rig, they would just spool up the pipe and move it to the next place and unspool it and reconnect it.
I didn't even know that was possible.
Oh yeah,
I hate to backtrack on you, but can you
yep,
walk us through what markets are needing this FM fittings? To me, I'm glad Pete brought this up, but we get a lot of questions from municipalities specifically, and everyone wants to know what the limiting factor is, right? You don't want to specify a project that the availability is difficult, the repair is difficult. Um, if I get a lot of questions when and where we need FM fittings, can you talk us through that and then kind of what's the
sure.
testing involved?
So FM that you're referring to is factory mutual pipe and fittings, not just limited to fittings. It's also pipe. So factory mutual pipe and fittings are typically used for any infrastructure fire water system that is going to be basically insured, right? So we'll typically see FM pipe and fittings at a chemical plant for their fire water loop infrastructure. We'll see it at power plants like these new combined cycle power plants that we're using for their systems. We'll see it at some of the data centers where they want to have their independent fire water loop system for the building infrastructure to come in and up to the building. We're not using polyethylene pipe in an FM function for like the sprinkler system inside the building. That's still traditional black iron or carbon steel, threaded pipe that they're using inside the building. But FM pipe and fittings, there's different ratings on it. So the ratings are FM 200, 250, and 335. And what that refers to is a pressure class. So pressure class 200 in our case is all DR11 polyethylene pipe with a working pressure rating of 200 psi. DR9 would be FM class 250, and DR7 is FM class 335. And those are the classifications. But typically, it's for all underground piping structures and fittings. The fittings have to also match the pressure class, and they also have to be factory mutual fittings. And what that requires is independent testing for a high pressure class. So it's basically, if you can think of when you're dealing with a fire, for the most part, the pipe is full of water and everything is static. And then all hell breaks loose and you're opening up all these valves and you get a big water hammer effect. And that is why they want factory mutual pipe to basically say this pipe has been tested and qualified at these higher pressures. Now, the reality is all pipe is made almost identical to the same way that an FM pipe and fitting responds. It's just a additional pressure test and serialized lot that we have to do for all FM fittings and pipe. And conversely, all FM pipe is made to an AWWA NSF 61 standard. So you're dealing with a water-based pipe for the FM systems.
Okay, and while I have you derailed, let me ask one more question, and I'll go to the background. So when people are buying, maybe a somewhat custom line, maybe 34-inch DR 13.5, something like that, where it's going to be difficult to get that off the shelf moving forward for a repair event, or if they do need some of these fabricated fittings. Is there a rule of thumb on how much additional pipe you tell people to buy for warehousing and or this fabrication you guys do?
Yeah, I mean, typically if you have 34 inch, you picked a beautiful number, right? 34 inch,
Very
28
custom.
inch, 26 inch, beautiful pieces of pipe. So typically we always have pipe that is in a heavier feedstock. What I mean by a heavier feedstock is anytime you're doing a fabricated fitting, the fitting needs to be what we call an equivalent dimensional ratio, an EDR. In other words, the fitting pressure rating must be equal to the pipe it's going to be fused into. Now, through a lot of testing and ASTM and ASME, anytime you're doing a fabricated fitting, the fitting itself, because of a mitered weld on these larger diameter fittings, has to be made out of a thicker or a heavier wall to accommodate the same hoop stress so that you don't have a D rating in that pipeline. So they're 34-inch 13.5 you could do out of 34-inch 11. You could do that out of 34-inch 9. You could also do that out of 36-inch 7. So as long as your IDs are pretty much close to the same, then you could machine it back down to the nominal pipe size to be able to be fused in, but then have enough wall thickness to accommodate the hoop stress reduction in that mitered weld for that fitting. So a good rule of thumb is if a guy's buying 34-inch pipe or one of these kind of, not going to say oddball, but they're trying to match up an ID for hydraulic flow, then the pipe, because it's got 2% carbon black, does not go bad. So they can leave it outside indefinitely and not have any degradation in the polyethylene pipe. So we always suggest that that they buy probably at least 5 to 10% more than they currently have on their as-builts or their alignment sheets. So it just works out. So don't buy 1,000 feet of pipe and then come back and say, oh, I need 25 more feet because I need to do a small extension and I missed it. So at least by 10% more is always kind of a good rule of thumb that we talk to the engineers about doing. But
Gotcha.
on a fitting, there's typically a workaround or two by going to a larger, thicker pipe and then being able to just fabricate and make a special reducer to get back into the 34-inch 13.5.
Peter and I were with our certified professional program last week, and there was a point where everyone was kind of just talking about things that have come up, and that was like a pain point that I realized. I'm not sure I've given people that advice as candidly in the past that they need to buy a little bit more and consider that fabrication, but I said it once, I'll say it again. Like, this is why you need to have, if you're a contractor, a relationship with your distributor, because they're foreseeing difficulties that, I mean, I don't know how people could, imagine something like that during procurement.
Right. I mean, what they can also look at, Dan, is not, if you do have a customer or a utility that gets stuck, needing let's go back to the 34-inch, right? 34-inch is not very common. Well, we could go to 32-inch, 30-inch dips, which is 32-inch IPS pipe. We could go to 36-inch, larger diameter, and then just put a small reducer on each end. The contractor can easily fuse that in. It's the same fusion machine for 34 or 36. And just as I said, as long as the wall thickness is equal to the pressure rating that they need, then going to a larger OD is not going to disrupt anything.
Okay.
Thanks for going into that, Dan. So, John, every time we talk, I mean, you always have great tales about what's going on in the field. One of the things we're going to do this year at Showcase is we're going to create a new award category for field guys and gals, because they're so important into what we do here at the Alliance and what the industry is trying to do. So that's coming up, and that's exciting. Do you see consistent misunderstandings or errors or challenges that your field customers have that you can share with our audience?
Yeah, I mean, it's all a function of training, right? So the equipment's getting smarter. The workforce is not getting dumber, but they're getting frustrated. So the workforce is frustrated in that they understand how they used to do things. And, probably 90% of the joints that we're involved with are all utilizing data loggers, which is, it's a terrific tool because it tells them immediately, are we doing the infrastructure correctly? Are we fusing this per the standards as outlined and set forth in the construction documents? And typically that's, per ASTM F2620 technical standards. So it tells them exactly how to do it. The equipment in getting smarter is not making our workforce dumber. It just frustrates them at times.
Right.
So if you have an older fusion tech and a construction guy that's used to manhandling things, the newer equipment is going to pick up that, you manhandled this, and you're going to get little bleeps and blops on your reports that some inspectors that are very particular are not going to like. So we spend a lot of time training the inspectors and everything else, the contractors in how to do it. One of the things about polyethylene pipe, Peter, as you know, is you really got to screw something up to get it to fail. And, you can have a gouge and a scratch graded, up to 10%, and the pipe is still fully pressure rated and is going to sit there for 50 plus years and never have a problem, you know?
So, talk about the data logger for a second.
Yeah.
I've been talking about the data logger for 10 years, back when we're on, I don't know, version 4. We're on
Hmm.
7 now. And, back then, John, I saw it as the route to better accountability.
Yep.
And, the PVC people would love to say, oh, you got to run the machine right and all these things. And so I, I think McElroy makes great products, but this is a fantastic product. And people just look at me like, really? Now it's like nobody's challenges the wisdom of a data logger. Do you find the same is true with your customers?
Absolutely. I mean, what it does is it protects not only the utility owners, but also the contractor, because it basically puts the onus back on the resin manufacturer and the extrusion manufacturer to basically say, well, wait a second, tell me what I did wrong. So, but the benefit of the data logger is it's like having a full-time inspector out there so that you don't have to watch every single joint. I mean, the joint failures are being decreased exponentially because of the data logger. And it's a training tool as well as a data recording device that basically is telling you, did I complete this fusion correctly? And if you just, as I say, you want to dummy it down, if you have nice rectangular boxes and you have the proper amount of heat soak and you have the proper amount of cooling time, then, you're fine. And, if the guy shortened his cooling time by 30 seconds, well, is that okay or not? Well, that's an inspector can say yes or no. But, when you have an 11 minute per inch of wall cooling time, trust me, that's enough time, especially with some of the advents of optimized cooling and some logarithms that have been created to speed up that process. Now, conversely, it clearly shows you when a guy screws up. And you can look at the profile of the bead and look at the data logger report, and you can clearly see, did we overpressure during the heating cycle? The bead is really big and flat. Did I not have enough time? Did I have a joint slip, when the machine came together? So the data logger is a fantastic tool and a training tool that we utilize all the time when we're doing in-field installations. And I mean, seriously, 95% of our contractors and infrastructure partners are utilizing the data logger. There's not hardly any fusion machine that is shipped or rented or sold without a data logger.
That's so cool. So you
Yeah.
mentioned something here I want to talk about, and that's McElroy optimized cooling.
Mm-hmm.
Give me a field story. You know, the data logger allows us to use that really pretty easily. And basically, for our audience, if you're not familiar, it just cuts down your fuse cool time. Tell me about a field story where they used optimized cooling and it made a difference.
Well, I mean, we're currently just finishing a project that had 162,000 feet of 20-inch dips, DR11 pipe or DR 13.5 pipe. Apologize for that. I should know. I sold the pipe, which was good. And on that, that cut the cooling time by 13 minutes per joint. Now it varied because we went from 40-degree temperature to 100-degree temperature, ambient temperature, which is the logarithm automatically accommodates a longer cooling time for the increased temperature of the ambient temperature versus the pipe temperature. But I think what we need to do is we need to give credit and reference also to what caused us to come up with this cooling time or optimized cooling. So if I may, I'll step back a few years. The ASTM standard of 11 minutes per inch of wall was an offshoot of the TR33, which was the Plastic Pipe Institute's first wave of a fusion standard. And that fusion standard was anywhere from 30 to 90 seconds per pipe diameter inch. Okay, so how do we get to 30 to 90 seconds? Well, if you have a very thin wall pipe, obviously it's going to cool off a little bit quicker, like a DR21 or a 32.5. And as we get into a heavier wall pipe, like a DR7, it's going to take a little bit longer for that to cool off. In the oil patch, at the start of what we call the cold bed methane run, which was old shallow lignite and coal fields would retain natural gas. They used to run polyethylene pipe because it was a low pressure gas gathering system. And there was the advent of what we call fast fusion equipment. And what fast fusion equipment did is they took the McElroy fusion equipment and they put it in a buggy that was enclosed, because in this case, most of this work was done up in the colder, snowy climates of North Dakota and Wyoming. And that was the advent of the fast fusion equipment. And what they found is that, well, wait a second, it's cold. Let me align this pipe and fuse it. And instead of cooling it for this long, we're just going to cool it for this long. And that technology led us to have McElroy do extensive testing to say, well, wait, okay, if they're doing all that, why are we doing 11 minutes per inch of wall? And that testing is what came up with the McElroy optimized cooling utilizing the data logger. So what we found is that the fast fuse equipment was not rough handling the joints. So define rough handling. Rough handling would be an operator made a 100-foot section of pipe, two 50-foot joints that were fused, and now he wants to wrap a strap and take a track hoe right at the fusion joint, pick it straight up and sling it over and drop it in the ditch, or go into a directional bore under stress. That is rough handling. But by lifting up on the hydraulic pipe lifts on either side and pulling the joint out 50 feet or driving the machine through the joint, that's not rough handling. And what we found through the extensive testing is that it did not degrade any of the fusion qualities or the structural integrity of the joint. And so that optimized cooling is really taken off big time, because if we're not rough handling, we're not going into a directional bore or trying to lift this assembly and sling it into a ditch and just go on the ground, has led to longer infrastructure projects being done much faster at a much more economical cost. But also, we're extremely busy in the field with equipment. And so as a result of that, we can do more pipe footage with one piece of equipment.
Yeah, you can get a lot more done more quickly. So
Absolutely.
Dan just did the numbers for us. So in that example, it was 3,250 joints, 704 hours of fusion time saved.
That is correct.
Time is money.
Time is money.
Yeah, so that's McElroy optimized cooling. And we now have our first history lesson on MOC, McElroy optimized cooling. Next, we'll have to get Jim Johnston on to corroborate everything you said.
Jim is the one that I used to say, we're getting our butt kicked here, by fast fuse. I want our own stuff. And that's where that all came out of, is
Wow,
Jim
good
Johnston
to know.
testing, and of course McElroy with their mixed snapper, which is their test unit that they did that with. They
so
tried to do everything on that, Peter. They put ice on it. They put cold nitrogen, everything, and didn't make a difference. Polyethylene is pretty inert.
Yeah, I followed up with them a couple of years ago because I have over 1 million joints now, I think, on optimized cooling. And I said, hey, do you have any failures? He said, not a one.
No.
So it looks like it's here to stay.
We also want to be smart with the contractors with that too. So, if we're doing a tie-in fusion where, like this large project, for this water infrastructure, the reason that polyethylene was chosen, this was out in the oil patch. And so we had 148 foreign line crossings that we had to do. So can you imagine if they were doing a traditional bell and spigot type pipe, 140 line crossings, they would have to have, excavated each one and pulled a shore box, and it would have been a ridiculous amount of time just to get the pipe joined. Well, with polyethylene pipe, what we were able to do is fuse up a 300 or 400 foot run of pipe, and then hydro excavate where these foreign line crossings were, and then be able to dig them out with traditional track hose, and then basically just pull the pipe underneath each of these foreign line crossings. So they had pipes sticking out of the ground every 300 to 500 foot sections for these crossings. Now we step back and we need to tie in those two joints. And those two joints, we would use the traditional 11 minutes per inch of wall for the traditional ASTM 2620 cooling time, because it is going to be under stress. So we were pulling the two pieces of pipe together, and there we want to use the traditional deal. So, and that worked out terrific. No problem. So it's a combination. You're not going to find something that just fits, only one type of fusion. So even though we use the optimized cooling for all the infrastructure runs, the tie-ins, the contractor and the training and the inspection is common sense to say, wait, is this going to be under stress? Let's let it cool a little bit longer in the machine. And
you mean under stress immediately?
Immediately. That is correct. Yeah, okay. Absolutely. As we complete the fusion.
Yeah. All right. Back to the field guys. Mm-hmm. So you mentioned optimized cooling and training on the data logger is important. What are some other things? Do they need reassurance and confidence building on the fusion process, the tie-ins, the fittings. What can our audience learn from your experience?
Yeah, I mean, there are you have two different types of trained contractors out there. You got guys that know how to fuse the pipe and they just want to blow and go, right? And that's fine. And there is a need for those individuals. There's also a slightly more advanced, or what I would call a more cognitive, higher class pipe fitter. And a pipe fitter fusion technician is thinking about, how do I square something up? I have a 90, I have a flange. How do I make sure that it's level, it's squared to the assembly, especially if you're going to need to hit a hard point on an above ground steel fitting, or an MJ adapter going into a ductile type gate valve for an above ground water infrastructure. So they need to think, well, what fusion do I need to do when, and how do I do that? And so it's a function of technical training and experience, that they're thinking ahead. Do I fuse this 90 in before I fuse the flange adapter on, or the MJ adapter on, or how do I come up with the length of pipe needed for an above ground riser? And so those training modules are field experience and a little bit more advanced. And so there is a combination. We were asked recently to develop a program for a community college for polyethylene infrastructure build. And so we worked very closely with Paul Brodsky with Macro University to help them use their LMS learning system and provide pipe and the equipment, so that we can get these community college guys and operators more education, so that when they're coming out into the field. So what's interesting about it is that and it's exciting about it, is we're seeing a breadth of the colleges understand that the workforce needs to be trained in utilizing fusion for polyethylene and other non-metallic piping, versus just, oh, I'm a steel welding class and I'm going to get an API, welding certificate. So the more training that we can do at the trade school level and the community college level is really going to benefit us in the field, and make my life a lot easier in having to go and babysit guys on projects. But that's an exciting new thing that we're seeing more and more of.
John, you're pretty versatile. I mean, you've got a lot of field experience.
Mhm.
You've got fabrication experience. You've got sales experience. There's a pretty important constituency out there called a civil engineer who's a consultant. Well, what are some of the techniques you've used to get buy-in from them? Because they're a pretty circumspect group. What's worked for you?
Well, just giving them actual field data and knowledge that they're not the first one to try to utilize polyethylene pipe for X, Y, or Z project. So the problems that we've run into with some of the engineering and the civil engineering firms in utilizing polyethylene pipe is, as I said, they're used to traditional, construction methods, where they're going to dig a trench, they're going to drop in a shore box, they're going to send a couple guys down, they're going to stab some joints together, and then they're going to go on. They're not used to fusing up a 40 or a 50-foot joint of pipe and then, snaking it underneath other infrastructure, because the pipe's going to break. No, the pipe's not going to break. We have a tremendous flexibility in the polyethylene pipe. So getting them to understand how the actual pipe itself and the fittings are fabricated and made, and how flexible and ease they are to install is been one of the points that we try to drive home with the civil engineering firms that has worked for us.
Yeah, nice. Dan, anything you want to ask of our good friend John before we take off here?
Yeah, great discussion of all the markets, but we are specifically focused on water. And this is something I've
Yeah.
been dealing with a lot lately. So engineers, that same civil market, they don't like when you're just telling them, hey, we can do something a handful of ways. But you talking to your contractor, you're like, hey, there's 5 ways to skin this cat. Whatever you think's easiest or most productive, or some people like spools and other would rather fabricate in the field. So my question to you is, ARVs in a traditional municipal water line, a transmission line. What do you think the best connection is to get? Do you prefer to go ahead and spool um, that outlet and then make the pop ends square in the field, or do you like to do a sidewall fusion in the field so you can identify that exact high point?
Dan, it's going to depend. Look, if you're dealing with a 8-inch, 10-inch, or a 12-inch line, even a 16-inch line, 18-inch line, pretty easy to just make a prefabricated spool piece like a 18 by 4, 18 by 3, 18 by 6
Mm-hmm.
branch saddle, fuse a pup piece of pipe on it, put a flange adapter so that they can put a valve and go. But when you're dealing with our 34-inch pipe, let's go back to your 34 that you love 34. Man, I got two connections on that 34 that I would need to square up to make sure that they're level to fuse in place, right? Because I have a spool piece that I'm going to send. In that case, fusing on a branch saddle, be it electrofusion or a sidewall fusion using a sidewinder or a 28 unit, anything up through an 8-inch outlet branch saddle is very easy to fuse in the field. So for a transmission water line where you want to put some air relief valves, or you want to put any sort of gauging or pressure gauge assembly, can easily be done directly in the field. So I mean, that's the way that we approach that. But if you have a little 8-inch or a 12-inch line, making two little 8-inch fusions are pretty simple to do, pretty easy to square that up. But when you have 34-inch pipe or 36-inch or 48-inch, doing that in the field, I would suggest that we just pipeline it, lay it in the ditch, and then go in and fuse on a branch saddle directly on top of the pipe or on the side or wherever you want it.
I
For
would
air
think it, I would think it'd be really dictated also by your confidence, John, in the crew.
Yeah, absolutely. And there's multiple ways to do it. And, you have electrofusion, you have a conventional sidewall fusion to do that. But, there are specialty contractors that, that dictate and understand how to do that, that do it every day. We do it every day here in the shop. We send field crews out to do it. We also train a lot of those specialty contractors on how to fuse that. I mean, kind of my rule of thumb that we're going to always stick to is you never want to be more than 50% of your main size for your outlet. So, if you got a 18-inch piece of pipe, we're going to stop at about an 8-inch outlet on that. We're not going to go an 18 by 12 or an 18 by 16. If you want to use a mechanical means to do something larger like that, just because you have to tap into that line, then we would suggest a full encirclement tapping saddle.
Makes
Kind of
sense.
like you traditionally have used.
So, okay, I hate to expand on this, but we're here. We're deep.
Yeah.
We're deep into this topic. So are you teaching this contractor to do a sidewall fusion then if they have to do a lot of these in the field? Are you training them and certifying them in a
Yeah, I mean, so
electric fusion, and then this becomes your third?
yeah, I mean, absolutely. So a lot of conventional fusion, Dan, where you're using a concave and a convex heater adapter
Mhm.
with either a sidewinder or a 28 or a specialty piece of equipment, which goes all the way up through McElroy makes them all the way up through a 36-inch sidewall machine. But yes, we you do testing, you do training. They understand, what the melt bead sequence looks like, what the preheat sequence looks like. And then of course on the electrofusion, it's equally important that they're qualified and trained so that they understand the proper techniques to get that saddle to fit on there. So that the pipe is clean, the pipe is peeled properly, that it's round, that they go through the proper sequence to make sure that saddle is on there. Once that's accomplished, then you do a pressure test against it to make sure everything's good before you tap it. And yeah, I mean, that's we do that all the time.
Okay.
Yeah.
Good work, Dan. Love the question. Hey, John, one final question here before we wrap up. What one thing could we as an industry do better to keep this thing marching along as great as it has been for the last decade?
Yeah. That's a good question, Peter. I have a good answer. So to keep this thing marching along, we all need to work together as one cohesive team. Um, and when I say that, I mean that in that we have great resin, we have great extrusion capacity and capabilities with all of the different manufacturers that are extruding pipe. We need to have a consistent training and certification method so that the contractors understand exactly what to do. Um, you know, I'm gonna go back in time again a little bit. There was a time. Well, let's just put it to you this way. In the early days of gasoline, it was kind of like the early days of polyethylene. If you used Texaco gas in your car, then everything was fine. If you used Union 76 gas in your truck, everything was fine. But gosh, if you put that Union 76 gas or that Texaco gas in somebody else's car that was using the other one, that's why your carburetor's all fouled up. So that's the way the polyethylene industry used to be. You could use my pipe and my fittings, but my fittings can't go on this guy's pipe, and that guy's fittings can't
Mhm.
go on this guy's pipe. And God forbid you would fuse one pipe to a different pipe. Today, it's all the same. It is a quality manufactured product from all the PPI registered manufacturers and systems, and from the resin manufacturers to the pipe extruders to the fitting fabricators. We all try to do the exact same thing so that you have a quality system. So, to make this thing continue to march forward, if we all continue with education and getting these outliers that are used to, I just want to do what the guy before me did, um, we'll be marching forward. So we just need to keep continuing to offer a quality solution in one voice, which we have, and then of course let the years of service speak for themselves. I mean, we're already exceeding 50 years of nasty integrated service that is not potable water or raw water. We're talking solvating chemicals and oil and gas and natural gas that have been in service for more than 50 years without any difficulty in that pipe. And that was 5 generations of polyethylene resin ago. So everything keeps getting better and better and better, and we just need to keep pushing forward with that.
Well said. Thank you, John Trimble. With that, guys, we need to wrap up because we have this 1 hour commitment to our audience. John, I so thank you and I'm grateful for you coming on today and learning. We need to do this again because you got a lot to say. You have a lot to share, and I'd love to go deeper into the field issues because I think that's particularly for me and some of my colleagues in this industry, that's an area where we need more knowledge, not less. So with that, I'll say thank you, and John, we will talk to you soon. See you on the road.
Sounds great. Thanks, Peter. Thanks, Dan.
All right. Thanks, Dan. So long, guys. See you on the next Poly Podcast.